Neil Armstrong had been getting ready for his mission on the moon for over 3 years. To resist microgravity conditions, he had to learn how to walk sideways by being strapped and suspended at an angle in trying to walk along walls. His limits were tested through an intense diet and sleep regimen, since in space he would only have beef and vegetables, previously dehydrated and stuffed into a package. Back in the day, astronauts had to experience the desert, jungle, open sea, and Arctic survival training. These days it's a lot more structured. But back then, it was more of a let's drop this person in the middle of nowhere with no supplies and see if they make it. Before landing on the moon, he had to gather and study rock samples in the Grand Canyon, explore ancient volcano formations in the Nevada National Security Site, and look into gas and lava vents, lava lakes, and pit craters in various locations in Hawaii. On July 20th, 1969, Armstrong was given a hearty breakfast before blastoff. Steak, eggs, toast, juice, and coffee. He received what doctors call a low-residue meal, which means he wouldn't have to go to the bathroom soon after. It took him 109 hours and 42 minutes to reach the surface of the moon, in an area called the Sea of Tranquility. He had to travel 240,000 miles to get there. The crew could have gone for the Ocean of Storms or the Central Bay, but this place was chosen for landing because it had good visibility, was relatively smooth, and was easily reachable with as little propellant as possible. When he was at about 500 feet above the surface of the moon, Armstrong had to maneuver the spacecraft manually to make sure they wouldn't land in a dangerous crater. He continued to hover for about a minute and a half, moving it sideways until he felt comfortable to land. As soon as his device landed safely, he immediately radioed to Mission Control, located in Houston, Texas. The now famous message,
"The Eagle has landed."
Steadily, he went down the Lunar's module's ladder, while a television camera was attached to the craft to record his progress. The camera also transmitted the signal back to Earth, where hundreds of millions of people were anxiously waiting. At precisely 10:56 p.m. EDT on the same day, Armstrong placed his feet onto the lunar soil, saying,
"It's one small step for man, one giant leap for mankind."
The schedule said that the astronaut needed to sleep before the first moonwalk, but he chose to go outside earlier than planned, since he obviously couldn't sleep. If Armstrong had walked on the moon without special equipment to breathe, he would have smelled a weird odor, sort of musty and sulfuric. Still, he had the chance to smell it when he returned to the lunar module. The thing is, the dirt had clung to his feet, so the odor spread all over the cabin. He described it as wet fireplace ashes, or how the air smells after fireworks shows. Who would have thought you needed to pack a scented candle when going to the moon? Apart from the people that have since made it to the moon, no one ever got the chance to know precisely what the crew was smelling. Even during that first mission, when moon soil and rock samples were transported to labs in airtight containers, once they were opened back on Earth, surprisingly, the smell was gone. He also felt the surface of the moon to be fine and powdery, but said he had no difficulty in moving around. One other member of his crew joined him about 20 minutes later. The whole moonwalk took a little over 2 hours. During this time, Armstrong and his teammates set up various devices on the surface of our satellite. One was meant to precisely measure the exact distance from there to Earth, by timing how long it took for a laser beam to travel from Earth to the lunar surface and back. Another meant to measure moonquakes and potential meteor impacts, which leads us to the discovery that the moon was pretty alive after all. We know today that the largest moonquakes are much weaker than the largest earthquakes, though their movements can last for up to an hour, way longer than on Earth. They managed to gather somewhere around 50 pounds of rock and soil samples. They also snapped many photographs of the terrain, where they also planted a US flag. The astronaut even got the chance to catch up with President Richard Nixon, for less than a minute though. The final thing on the list for Armstrong was to go for a walk to what is now known as East Crater, 65 yards east of the lunar module. It was the greatest distance traveled from the spacecraft on that specific mission, approximately the length of half a football field. As soon as his tasks were done, Armstrong went back into the lunar module and safely closed the hatch to get some sleep. While preparing for liftoff, Armstrong and his crew discovered that, because of their chunky spacesuits, they managed to break the ignition switch for the ascent engine. No big deal, they thought. So they used a part of a pen to push in the circuit breaker to start the launch sequence. At 1:54 p.m., the famous Eagle began to ascend. Apart from the scientific equipment installed on the surface of the moon, a plaque was also left there. It read, "Here, men from the planet Earth first set foot upon the moon, July 1969 AD. We came in peace for all mankind." Years later, Armstrong said that NASA limited their time on the moon because they didn't know how the spacesuits would handle the moon's extreme temperatures, as high as 260 degrees Fahrenheit during the day, to as low as 280 degrees Fahrenheit below zero at night. Things got a bit more complicated when Armstrong landed back on Earth, since he had been exposed to unknown space particles. The result? He and his team had to be placed in planetary protection quarantine on their return, as soon as their space capsule safely splashed down in the Pacific Ocean on July 24th. That specific quarantine for the Apollo 11 astronauts is one of the reasons why we have microwaves in our kitchens today. When they first returned from the moon, they initially spent their first few days in a mobile quarantine facility, or MQF. Sure, the MQF featured comfortable chairs, bunks, a toilet, and showers, but it didn't leave a lot of space for fancy cooking. Since there was no room for a standard oven or grill, and to also reduce the potential fires that might have occurred, NASA had to get creative. That's how the original countertop microwave oven was developed, to easily help astronauts get their meals without the hustle of a fully equipped kitchen. These days, you can see that first microwave in a museum in Oakland, California. After returning to Earth, Armstrong claimed he would never reach for the stars again. But he didn't stop exploring, though. Back in 1985, he joined a professional team of other greatest explorers to the North Pole. He was joined by mountaineer Edmund Hillary, aviator Steve Fawcett, and photographer Patrick Morrow, reaching the pole on April 6, 1985. Armstrong claimed he wanted to see what the Earth's icy pole looked like from the ground, since he had only seen it from the surface of the moon. The Apollo 11 mission was nevertheless unforgettable for Armstrong since. In 2015, the Smithsonian Institution uncovered that he had kept hidden a cloth bag full of small parts from the lunar module. It included his waist tether, some utility lights, and their brackets, an emergency wrench, and the optical sight that was mounted above Armstrong's window of the space module. It also contained the data acquisition camera that recorded the iconic footage of Armstrong taking his small step on the moon. Armstrong kept it to himself for many years, until his widow, Carol, eventually found it. He even kept it a secret from his official biographer, who had many times asked if he had kept any memorabilia from his famous mission. He didn't sneak those objects back on Earth, though. He just mentioned it to be a bunch of trash he wanted to bring back.
When you see it in the sky, it looks round, but the moon is more of an oval shape, similar to a lemon. This shape, flattened with a bulge on each side, came out billions of years ago when extremely hot tidal forces shaped its crust. They heated up some regions more than others. Gravity from our planet has helped to exaggerate this lemon shape over time. When they were getting ready to send missions to the moon, some researchers were worried because there was a thick layer of dust on the lunar surface. They were afraid seas of dust were both soft and thick enough to swallow their lunar lander. But even though the surface there is dusty, this layer is just too thin to cause complications. Our moon certainly isn't the biggest one in the solar system. The champion here is Ganymede, one of the 79 moons circling around Jupiter. But our moon is the largest in relation to its parent planet, It has a diameter of more than 2,000 miles, which is slightly bigger than the quarter of the size of the Earth. Pluto, for instance, has a smaller moon-to-planet ratio. Its biggest moon, Charon, is almost the size of Pluto, which is why it looks like a double dwarf planet system. How long would a walk around the moon take you? When the Apollo astronauts were there, they managed a walking speed of approximately 1.3 miles per hour. On average, you walk twice as fast down on Earth. The low gravitational force on the moon would give you significantly less traction on the ground. But those special spacesuits astronauts were wearing were never actually designed for long-distance hikes. In theory, you could maybe reach the speed of 3 miles per hour before you'd need to break into a run. At this pace, you travel 6,770 miles, which means making a circle around the moon in 91 days if you're walking non-stop. Why does the moon change its shape? It goes through different phases each month, starting from the new moon and gradually going to the full moon, just to do the same thing all over again, but in reverse. The sunlight hits one half of the moon at a time. This gives it a night and a day side, just like we have it here on Earth. The shape we see the moon in depends on where it's located compared to the sun. If it's directly between us and the sunlight only hits the side we don't see. That's a new moon. It appears completely dark in that phase. But when it comes to the far side of our planet from the sun, its day side completely faces the Earth. That's when we see a full moon. After the initial phase, when the moon is new, we'll see more of its surface in the sky as it orbits our planet. It's something we call waxing. The moon in this phase first becomes a crescent. The first quarter moon is when it's half full. After that, it goes into a gibbous moon phase, when it's larger than half full, but not yet full. After it reaches the full moon phase, it slowly shrinks and goes through the same phases but in the opposite direction. While up on the moon, you'd probably see human footprints there. True, no one has stepped there since the last Apollo mission in 1972. And the footsteps may stay there for many years because there's no geological activities on the moon, like earthquakes or volcanoes. There are no winds, rain, or other things that could erase these footprints. How would you get to the moon? Rockets are probably the first thing that comes to your mind, but a lunar elevator could be an even better solution, because traveling in a rocket would be a difficult, expensive, and pretty dangerous way to try to reach the lunar surface. Why would people want to go there? It's not just about craters, an amazing view of our home planet, or other unique things the moon offers. It's also full of resources like a rare form of helium. Humans could use it in fusion power stations on Earth. We could extract some other rare elements too, and use them for smartphones and other gadgets. For a lunar elevator, we need to stretch a cable anchored to the moon's surface for 250,000 miles towards the Earth. We wouldn't be able to attach it directly to our planet because both Earth and the moon are moving. But we could terminate high in our planet's orbit. We'd have solar-powered robotic shuttles that would move up and down the cable. This is like having a conveyor belt to ferry rare and precious resources our way. The cable would be as thick as a pencil and would weigh 40 tons. It sounds expensive, but a lunar elevator would most likely pay for itself within only 53 trips. The moon is in constant motion. It rotates on its axis and circles around the Earth, and it makes the same amount of time for the moon to make a circle around the Earth and rotate once on its axis, compared to our planet, which rotates on its axis every 24 hours, and makes a full circle around the sun in 365 days. So, the moon is tidally locked to our planet, which is why we always see the same side of the moon. One theory says the moon probably formed when a large Mars-sized object from our solar system hit the Earth. They collided 4.5 billion years ago when the solar system was still in its early stage, which was pretty chaotic. If this theory is correct, around 60% of the moon is made of lighter elements that are also present in the outer layer of our planet. A lucky set of circumstances lets us see total solar eclipses from our planet. The moon is the perfect size and distance from the Earth to appear the same size as the Sun when we're looking at it in the sky. When the Moon passes between the Sun and us, it covers the Sun perfectly. Plus, you can see an impressive halo that illuminates its edges. If it were any farther from us or smaller, a solar eclipse would only look like there's a blot on the Sun. Our Moon contains the water that kinda jumps around. There's water there locked up in ice. Some water molecules move around the surface as the Moon cools and warms during the day. The water gets stuck on its surface until the lunar midday, when the Sun is above the upper branch of any of the Moon's meridians. At this point, some of the water melts, heats up, and ends up in the delicate lunar atmosphere. Its atmosphere generally contains some unusual gases, including potassium and sodium. Venus, Mars, and Earth don't have these in their atmospheres, so the water stays and floats there until it gets to a cooler area. Then it settles back to the surface. There's a specific anomaly under the surface of the South Pole of the Moon, a giant and extremely dense blob of metal lodged in the mantle. And, most likely, it's altering the Moon's gravitational field. No one knows how such a huge blob of metal ended up trapped under the lunar surface. It could perhaps be remnants of the iron-nickel asteroid. 4 billion years ago, this asteroid crashed into the far side of the lunar surface and created this enormous South Pole Aitken crater. Our natural satellite is shrinking. Its interior is cooling, which results in the Moon getting over 150 feet skinnier, just as a grape wrinkles as it's shrinking down. But a grape has flexible skin, and the lunar surface crust is brittle. That's why it breaks as the Moon is getting smaller. That way, it forms thrust faults. One section of crust pushes over the closest part. This has been going on for the past few 100 million years. These lunar faults are still active. They probably produce moonquakes as the Moon gradually shrinks and cools all the time. Some of these quakes are strong, maybe 5 on the Richter scale. During their orbit around the Moon, astronauts took images of Ina, a quite unusual volcanic deposit. Ina is not that old. It might have been formed somewhere between 3.5 and 1 billion years ago. The volcanoes on the Moon were probably active during the age of dinosaurs. If only they could have invented telescopes. They'd probably have a magnificent view of lava oozing from the lunar surface from time to time. The Moon has its own time zone called Lunar Standard Time. It doesn't correspond with the time on our planet. A year on the Moon lasts 12 days. Each day is about as long as a month on Earth. These days got their names after astronauts who walked on the Moon. The days are divided into 30 cycles. The cycles are divided into hours, minutes, and seconds. The calendar started when Neil Armstrong set his foot on the Moon on July 21st, 1969.
Breaking news! Mercury is getting smaller. Well, we used to think that our planet was the only one in the solar system that had tectonic activities, meaning that the planet releases heat because plates under the crust move, which changes the surface and eventually makes the planet smaller. But it happens on Mercury too. Researchers took pictures of the planet back in 2016. These pictures showed landforms that were reminiscent of cliffs. They're called fault scarps. Since they are relatively small, the team believes they were formed not very long ago, which means Mercury is still contracting, even 4.5 billion years after the solar system formed. Mercury has a solid inner core, and there's a liquid metal outer core that surrounds it. It's still going through a cooling process. In fact, all rocky planets are still cooling from the times when they were initially formed. As those liquid parts of the planet's core become more solid, the planet contracts and becomes smaller. How come you don't see planets twinkling like stars? If you were up in space, you wouldn't see stars twinkling. But on Earth, you see it because of the atmosphere. Our protective blanket of air refracts the light of stars, which means it scatters it in a zigzag pattern. We perceive this as the twinkle. Planets appear way bigger than just pinpoints. Their light also zigs and zags after hitting the Earth's atmosphere, but these motions kinda cancel each other out, which is why we see their steady light. Now, if you brought a block of lead on Venus, it would melt like a block of ice on our home planet. The surface temperature on Venus goes up to 900 degrees Fahrenheit. Even when researchers send spacecraft up there, it can't withstand the environment for too long. One craft, for instance, landed there in 1982 and managed to stay for only 2 hours. But a team still got the first color pictures of Venus and analyzed some of the planet's soil. Planets collide with asteroids, comets, other planets, and the rest of the celestial bodies that move through space. But galaxies also collide. Milky Way, our galaxy, is about 2.5 million light-years away from Andromeda, our closest galaxy neighbor. They are getting closer and speeding toward each other at 250,000 miles per hour. It's inevitable. One day they'll collide and everything will change. Two galaxies will merge into one brand new, unique one. And some planets and stars won't survive. But, according to predictions, this won't happen for another 4 billion years. Plenty of time to, well, do most anything. The combination of the gravity on our planet and the gravitational force of the moon leads to changes in ocean tides. So, when you jump, you're pulled back to the land because of the invisible force that pulls things toward each other called fill in the blank. Gravity. Good for you. The moon has about 80 times smaller mass than the Earth, but it still has a gravitational pull. As our planet rotates, the moon's gravitational pull influences the closest part of the Earth. It affects the whole planet, not just the water. But the land is denser than the water, which is why we see the effects of the moon's gravity on the water only. And the results are the tides. On the opposite side of our planet, the one that's farthest from the moon and where the moon's gravity is the weakest, the tide is high because the moon pulls the rest of the Earth towards itself, away from us. What do you think space smells like? Well, you can't actually smell it because your nose doesn't work in a vacuum. But astronauts that work aboard the ISS have said they've noticed a specific metallic aroma on the surface of their spacesuits after repressurizing the airlock. They compared it to the odor of welding fumes. Other things in space have a specific smell too. For instance, there's a lot of hydrogen sulfide in the atmosphere of Uranus, which smells like rotten eggs. Venus and Mars have a similar odor. The atmosphere on Mercury is quite sparse, which means it doesn't have much of a smell. On Jupiter, it depends where you are in the atmosphere. Some parts have high levels of ammonia, so you'd smell something like cleaning fluid. Other parts have an egg-like smell, but the rest, the parts with high levels of hydrogen cyanide, smells like bitter almonds. And you don't want to take a big whiff of that, trust me. Here on our planet, when you try to fuse two metal bits together, you have to apply enough heat that the metal gets to its melting point. It's way simpler up in space. You don't need heat or any action at all to stick two pieces of metal together forever. It's something we know as cold welding. It happens when the metal bits slide over each other. They have protective oxide layers. On the Earth, that's something that stops them from fusing. But in space, this type of protection is gone. So the electrons from one metal piece simply flow into the other one and they become one. There are rocks from space all over the Earth. In 1996, a geologist found a rock in the Sahara Desert. After studying its composition, scientists realized they hadn't seen anything like it before, even on other planets or with other meteorites. One theory says this stone was even older than our solar system. It had a specific combination of elements that was probably characteristic of early solar nebula. Pluto was demoted from a planet to a dwarf planet, partially because of another dwarf planet called Eris. Eris was found in 2005. It has a similar size as Pluto, so astronomers were worried that the number of space bodies that orbit the Sun and that are waiting to be discovered might have been compromised when it comes to being an official planet. So, after they discovered Eris, they set up new standards for a celestial body to be called a planet. Round, orbit the Sun, and orbit clear of small objects are just some of the criteria for a celestial body to be considered as a planet. And you have to score well on the SAT. There are more than 20,000 pieces of space junk that humans created, circling around our planet. And these are just the pieces that are larger than a softball, while the real number of total pieces our researchers track is way bigger, somewhere around 500,000. There are millions of bits so small we can't even track them. In space, junk can move at high speeds, sometimes more than 17,500 miles per hour. That means even small objects, like a chip of paint, can damage an operational spacecraft. So the International Space Station has to carefully maneuver itself to avoid space junk. And there's another potential problem there. It's called Kessler syndrome. When there's so much junk in low orbit of our planet, it smashes together, which leads to more and more debris, like some sort of space domino effect. One of the potential ways to solve this is by using nets that would push the objects into our atmosphere, and then we could clean up at least some of the space junk. Neptune has a pretty interesting moon called Triton. It kind of reminds us of Pluto because of its similar composition, but it's also in retrograde orbit. Triton is probably one of the icy objects in the Kuiper Belt. Neptune's gravity probably trapped it at some point and turned it into its own moon because Triton has been orbiting Neptune ever since, and it's been doing it in the opposite direction that Neptune is rotating. One of Triton's coolest features is its erupting geysers. There's water on two of Saturn's moons. The first one, Enceladus, has a whole ocean made up of salt water. And based on some complex organic molecules, there could even be a sign there's some form of life. But this is just a theory that no one can yet confirm. Titan, the other moon, could also have signs of life. Any place in space that has both carbon-containing chemicals and water is a potential home for some form of living organism. What's the coldest planet in our solar system? Your first thought is probably Neptune, since it's the farthest planet from the Sun. But it's actually Uranus. It's 20 times further away from the Sun than we are. The average temperature at its cloud tops, and that's what we call the surface temperature in gas giants since they don't have a solid surface, is minus 315 degrees Fahrenheit. Enough to give you a bad case of freezer burn. Planets that are so far away from our Sun can't get much heat, which is why some heat comes from their core, similar to how the core of our planet is hotter than the surface. But it's not enough, so both Neptune and Uranus are cold. But Neptune has methane in its atmosphere. On Earth, methane is a greenhouse gas, which means it traps heat like a thick jacket that keeps you warm. And Uranus has less methane in its atmosphere, which is why it's a bit colder than Neptune, even though Neptune is farther. Speaking of Uranus, did you know a season there lasts for one pretty long day? Yup, that one day is equal to 42 years. The planet makes a single circle on its axis in 17 hours, but its tilt is so pronounced that one or the other pole is mostly directed towards the Sun. This means that a day on the planet's north pole lasts 42 Earth years, which is half of a Uranian year. So if you could go to Uranus and stand on its north pole, you'd see the sunrise in the sky. You'd circle around for the entire summer, after which you'd face 42 years of darkness and winter. No thanks, I'll stay here.